Now we're going to go ahead and switch over to multiplication and division. Before we do that, let's review how you multiply. When it comes to multiplying fractions, there's actually two rules of thought of how to do it. I'm going to show both, and I'll show you which one I actually prefer when we talk about rational functions. So one thing people will do is just automatically multiply straight across. So 1 times 8 is 8, 2 times 5 is 10, and then they'll simplify by finding common factors. So in this case, 8 and 10 are both divisible by 2, so essentially you're dividing both by 2, and you get 4/5 as your answer. Now, the second method people use is they actually simplify before they multiply across. And the way they simplify is they look at every top or each numerator and they see if there's a common factor that we can divide out. Now, 1 you never worry about, but 8, for instance, looking at both denominators, 8 and 5 don't have a common factor, but 8 and 2 have a common factor of 2. So I'm going to divide both of those by 2. And then 5 doesn't have a common factor with anything on the top. So at this point, then they'll multiply straight across. So they get 4. 1 times 5 is 5, and the answer. This is the method we're going to go through whenever we rationalize, or not rationalize, simplify rational functions. So division, I'll show that same thing with the division. But division is, you have a step that you have to do before. Some people call it the copy dot flip method. So you copy the first, put a dot, and flip the second. So copy dot flip. I just always say your division is the same as multiplying by the reciprocal. Same idea. Okay, so copy dot flip or whatever you want. At this point, same idea, you're going to look at the numerator. So the only numerator we really care about is the 9 because 1 doesn't do anything. And we see if any of the denominators are divisible by 9 or have a common factor, and they do. So 3 and 9 do. They both have a common factor of 3. So divide them both by 3, and then I multiply straight across. 1 times 3 is 3. 1 times 7 is 7. And there is my answer. So let's see how this works with rational functions. So let's start with this one. We're simplifying this one. Notice I'm not going to have us do excluded values. We're just going to simplify. So the reason I showed you that other method, what we're going to do is we're going to find common factors first, which means we need to factor first. And this time when there's multiplication division, there can be up to 4 different things we have to factor. So all 4 of these need to be factored in the end. I'll do blue. Oh, beautiful. Okay, so x squared minus 4 is perfect squares. So we've got x plus 2, x minus 2, difference of perfect squares, I should say. And just so you know where I'm pulling everything, that comes red matches with red. X squared minus 1 is also a difference of perfect squares. So that's x plus 1, x minus 1. And so that was the yellow. And then we've got the green. There's a greatest common factor of 6. There's no exponent on the x, so I know I'm only looking for greatest common factor in that case. So that one's done. And same with the bottom one. There's no visible, I should say there is an exponent. There's no visible exponent, so the exponent for both of these are 1, which means at most you're looking for a greatest common factor. So 2 is our greatest common factor. And now, before we even multiply, this is where I was mentioning that you're going to simplify first. So for instance, on this numerator right here, there's an x plus 2, and down here on this denominator there's an x plus 2, so those can actually cancel, as long as one of them's in the numerator, one's in the denominator. There's no other x minus 2, so I'm going to skip that one. We've got this x minus 1, though, right here and right there, so those two can cancel. And then last but not least, 6 over 2, those are both divisible by 2, so 6 divided by 2 is 3, 2 divided by 2 is 1, and then I'm going to go ahead and multiply straight across with everything that's left over. So there's the 3 left over. I like to write that one first. And then on the top, there's just x minus 2. On the bottom, there's a 1. I don't need to write that, but there is an x plus 1. You can put it in parentheses. You don't have to, though. That's your answer. Let's see another one. So here's another multiplication. Same idea. We're going to first factor. So maybe I should write that out. I'm not going to highlight it as intense as I did last time. So 2x squared plus 7x plus 6. That factors to 2x plus 3x plus 2. So it's a trinomial. This is twice as big as the middle exponent, remember? So you use whatever method you use for trinomials, whether it be the grouping method or box method or the method Mrs. Langford teaches, whatever. The bottom one, x squared minus x, your greatest common factor is an x, and then you get x minus 1. 4x squared is just a single term, so that doesn't factor. 4x squared minus 9, that's a difference of perfect squares, so we get 2x plus 3, 2x minus 3. And then anything I see in the numerator that matches with anything in any of the denominators, I get rid of. It's common factors. Now this one is one that people miss a lot, but technically x squared is the same thing as x times x, right? And there's an x right here, so we can get rid of one of the x's as well. And that looks like it's it. So my answer, I would have 4x and then x plus 2 on the top, because I'm just multiplying straight across and combining everything. We've got this x minus 1 and that 2x minus 3. And there is our answer. Let's switch over to a division problem. It's not much different, but in fact, it's pretty much the same. You just have to do one extra step. So I'll do that extra step first. I have 18x plus 9 over 6x squared plus 3x. So I copy the first one, dot, and then flip the second one, 5x cubed over 10. And then I just start factoring. That's the word. So this first one on the first numerator right here has a greatest common factor of 9, and then there's 2x plus 1. Second one has a greatest common factor of 3x, and then I have 2x plus 1. Then I have 5x cubed, that doesn't change, 10 doesn't change. Let's start getting rid of common factors. 2x plus 1 is gone. Now remember, we've got an x cubed, so that means we're multiplying x together 3 times and an x. So we're going to get rid of that x and then take out one of those x's, so it's now squared. Next, 9 and 3 are divisible by 3, so that'd be 3. 9 divided by 3 is 3. 3 divided by 3 is 1. And 5 and 10 are both divisible by 5, so 5 divided by 5 is 1. 10 divided by 5 is 2. So let's figure out what we're left over with. So we've got a 3 times 1, so that's 3. And then we still have x squared. And then 1 times 2 is all that's left, so just this 1 times that 2. So we just have a 2 on the bottom. Oops. And that is the answer.